right, let's take this example here of finding the volume, or as we would call it, the volume of the region below x squared plus y squared plus z squared equals 4, which is, of course, below a sphere of radius 2, and above z equals square root of x squared plus y squared, so it's above a cone. So we did this with the cylindrical coordinates also. This was, basically our ice cream cone picture. Okay, so there's sort of our view of the ice cream cone. Okay, not drawn to scale, just keep that in mind. So if we're going to then find this area, or I should say volume, so the volume, we've got our triple integral. We'll come back to put in the limits of integration. And if we're going to go with spherical coordinates, we need a rho squared sine of phi. And then it needs to be a d phi, d rho, and a d theta. These are starting to look all the same, aren't they? Okay. Now, the phi values, okay, if you recall, the phi is, when we're integrating that, it's the angle from the z-axis. So, let's put the origin down here, okay? And then that makes our phi values then the angle that we're measuring outward, that direction. So that's going to go from the top until we hit the side of the cone here. And the cone itself is at 45-degree angle, or a pi over 4 angle from that z-axis. And so we're going to be integrating that then from 0 to pi over 4. Next is the d rho, and rho is, we're going to be integrating from 0 out to the edge in all places. Well, that's our radius of 2, so that's integrating 0 to 2. And then finally our theta values. Our theta values then, this is our angles here around the z-axis and the xy plane. Well, the theta values there is going to go all the way around, so that's going to be a 0 to 2 pi. Now, in order to do this triple integral then, all three of these are actually completely unrelated in a sense. If we look at this d phi piece, well, we have the sine of phi, and the rho has nothing to do with it. None of the limits of integration have anything to do with it, so we can do that integral as one entity. In a similar manner, the d rho, there's our rho squared, and that's this integral. So we can write that separate. And then finally the d theta is just you're integrating the number 1. So putting that all together, our 0 to 2 pi of d theta, so that's the theta. Then in green here, our rho is our integral 0 to 2 of rho squared d rho. And finally the last one in yellow is 0 to pi over 4 of sine of phi. Okay, that's really crappy. Try again. Sine of phi, d phi. Okay, so these are all separate, right? You can integrate each three and multiply them together. And we might as well carry this out here. So let's see. So our first integral, obviously we're integrating 1 from 0 to 2 pi, that's just 2 pi. This integral, our antiderivative, is 1/3 rho cubed from 0 to 2. And then this one is a negative cosine phi. I can't write that today. From 0 to pi over 4. Okay, so here we're going to plug in a 2. We're going to get a 2 cubed times 1/3 is an 8/3. And then plug in a 0, you get nothing new. So you get that. And then plugging in here, you get our negative cosine of pi over 4. That's root 2 over 2. Minus a negative cosine of 0, which is 1. And that's it.